Hello and welcome to this next video on light, and this video is on the topic of refraction and refractive index. This is our second topic video. So let us start with the theory of it. The broken pen illusion occurs because light is bent by the glass block. So what is happening here? You're holding a pen behind a glass block. What appears? It appears as if the pen is broken in between. Why does it happen? It happens because of refraction. The bending of light is called refraction. Whenever the light travels from one kind of a transparent medium to another kind of a transparent medium, it bends. Transparent medium, can you give me some example of transparent medium? Yes, you are right. Water is transparent, glass is transparent, and there are many other things around us which you can think of. For example, oil is transparent, petrol is transparent. So many transparent objects around us. So whenever the light which is traveling in one transparent medium and it crosses and passes into another transparent medium, it bends. Let us understand it in the next slide. So let us understand the concept of refraction. Let us look at the pictures here. Picture number 1. Let us call it picture number 1 and picture number 2. Let us not read what is written on the screen first. Let us focus on the pictures. So what is happening in the picture? The light is coming from the air. Look at the arrow. The light is coming from the air, right, like this, and it is entering the glass. The light is moving from a rarer medium to a denser medium. Rarer means less density, denser means to a high density. Light is moving from a less density medium, which is air, into a high density medium, which is glass. Whereas in picture 2, the light is moving from a high density medium, which is glass, into a less density medium, which is air. Look at the arrow. Arrow is showing that the light is coming from the glass, from inside the glass, and it is emerging out in the air, right? And in both the scenarios, if you see, the light is bending. It is bending at this point at the boundary of air and the glass. Here as well, in the second picture also, the light is bending at the boundary of the glass and the air. The light is bending. That means refraction is happening. What is refraction? Refraction is the bending of the light when it enters from one transparent medium to another. We see the refraction happening in both the cases, but there is a slight difference in the refraction that you see that is happening in both the cases. Let us write the angle of incidence, I. Angle between the incident ray and the normal is called your angle of incidence. Angle between the refracted ray, this is your refracted ray. Refracted ray. Refracted ray is the ray which has bent, right? This is your angle of refraction. If you compare both the angles, here if you see, I is greater than R. If you look at the picture 2, I and R, mark them. In the second picture, I is less than R. So what do you infer? The light, when it moves from a rarer medium to a denser medium, it is bending towards the normal. So let us read the text now. The light ray travels from the air to glass. Its speed is reducing. It bends towards the normal. I is more than R. That means it is moving closer to the normal. It is bending towards the normal. Why is it bending towards the normal? The reason lies on the speed. The speed is going down. Why the speed is going down? When the light is moving in the air, it is moving in a low density region. It is colliding with lesser number of atoms and molecules, therefore it has high speed. Think of you yourself driving on a highway, very less traffic, you move at a high speed. But as soon as you enter a traffic road, your speed goes down. Same thing, when the light enters the glass is a solid lot of atoms and molecules tightly packed, the speed is going down in the glass. The speed is going down. Because the speed goes down, angle with the normal also goes down. Alright, what is happening in the second picture now? Let us read the text. When the light ray travels from the glass to air, here it is traveling from glass to air, what is happening to the speed? Speed is increasing. High density to low density, speed is going up. As a result, it moves away from the normal. This is a case of dense to a rare medium. Whenever the light travels from dense to a rare medium, it moves away from the normal. Whenever the light moves from rarer to denser medium, it moves towards the normal. So please do remember this concept. And if you do forget, we have a short form for this as well. You can just make a note of it. Remember the acronym FAST. The light gets faster, it moves away. Fast away, slow towards. Fast away, slow towards. The light is getting fast, it is moving away from the normal. Slow, it is moving towards the normal. Right? This is the simple concept that defines refraction, the most of the things, significant things that you should know about refraction. Similar to the law of reflection, in refraction also we have a law which is called the law of refraction. Law of refraction says sin I over sin R is equal to the speed of incident light wave over the speed of refracted light wave, where the angle I and R are respectively the angle of incidence and the angle of refraction. So this is your law of refraction. What is refractive index? Another thing to note for the students, take out your notebooks and pens, write down the formula for the refractive index. Different transparent medium, they have a different refractive index. So the refractive index is found for a substance. Refractive index of a substance N is defined as speed of the light in the air divided by the speed of the light in that substance. So for example, in air, the speed of the light we know is 300,000 kilometers per second. If in glass, the speed of light we know is 200,000 kilometers per second. Therefore, the refractive index will be equal to the speed of the light in air over the speed of the light in glass. So, how much is the speed of the light in air? Substitute the values in the equation, you will find the refractive index of the glass. Right? To find the refractive index of any substance N, you need to know the speed of the light in that substance, because the speed of the light in air is already a known factor which is a constant number. If you can know the speed of the light in water, you can find the refractive index of water. We'll be solving questions on this. So far, please make notes of all the formulas, and as you apply these formulas, all these things will make perfect sense. Now you can combine the law of refraction together with the formula for refractive index. So let us understand how we do that. The law of refraction is written in this blue box. Sin I over sin R, speed of incident light wave over speed of refracted light wave. This is your law of refraction. So for the light traveling from air into the transparent medium. So if the light is coming from the air, that means the incident ray is in the air, right? And it is entering into a transparent medium. So let us understand what is happening here. For the light traveling from the air, it is traveling from the air into the transparent medium. So where is your incident light? Where is your incident ray? Incident ray is in the air. And where is your refracted ray? it is in the transparent medium. Speed of the incident light ray becomes the speed of the light in air, because the incident light is in the air. Speed of the light in air. Speed of the reflected light wave. Reflected light ray is in the substance. The substance can be your glass, air, glass, water, or any other transparent medium. So speed of the light in the substance. Alright. Next thing to understand. Now we are taking the formula for the refractive index. The refractive index of the substance N. If you have made your notes on the formula for refractive index, go to it. What is the formula for refractive index? Speed of the light in the air divided by the speed of the light in the substance. That's the formula for refractive index. Take this formula and substitute in this above formula. So what does it give you? It gives you sine I over sine R is equal to N. For any further questions, type in the comment box and let me know. I'll clarify it in more details. So we are starting here with the law of refraction, right? And the second part of the equation, the right hand side changes to something like this. Why? Because the incident ray is in the air and the refracted ray is in the substance. So this whole equation becomes something like this: speed of the light in air over the speed of the light in the substance. And we know that this whole thing is the refractive index. So therefore sine I over sine R is N. So I am going through it again. I summarized it again so that you can clarify. It can clarify all your doubts and you can understand it well. Right? So when we combine these two equations, when we combine the law of refraction together with the formula for refractive index, we get that sine I over sine R is equal to the refractive index of the substance. So what is the purpose of this formula? If we are given any of the two values, say that if you are given I, angle of incidence, and the refractive index, you can straight away get the value of the angle of refraction. We can calculate R by rearranging the above equation as this. Substitute the values in this equation and you can find the value of R. Different substances, they have different refractive indexes. Diamond, if you see, it has a very high refractive index. What does it mean? The diamond can bend the light so much. That's why diamonds are so shiny and therefore so sparkly, right? Refractive index is high. Glass, acrylic, plastic, water, every different material have a different value of their refractive index. More is the refractive index, the more they bend the light. Alright, so here we'll take up an example so that it can clarify your doubts on the working of the formulas that we have learned in this chapter. The refractive index for water is 1.3. Okay, a ray of light enters a flat water surface at an angle of incidence of 35 degrees. Calculate the angle of refraction of the light ray. So let us understand what is happening. Always a good idea to draw a picture. You have your air, you have your water. A ray of light enters a flat surface, flat water surface. So the ray of light is coming all the way from the air. Let this be your normal. I am drawing the normal as a dotted line and it enters the water. At an angle of incidence, I is how much? 35 degrees. The refractive index for the water, let's call it NW, is given to you 1.33. Calculate the refraction, angle of refraction. Now you should remember sine I over sine R is equal to n. So all that you have to do is substitute the value. So sine r is how much? Sine of r is sine I over n. Sine of 35 degrees over n is 1.33. If you can solve this, this will give you your answer for part A. Right, so this is where we solve the part A. Let us come to the part B. The speed of the light in the air is given to you. Calculate the speed of the light in the water. Here we will use the formula for the refractive index. Refractive index formula said speed in air over the speed in water. Refractive index of what? Refractive index of water is equal to speed of the light in air divided by the speed of the light in water. So this whole thing becomes, how much is the speed of the light in water? Speed in water is equal to speed of the light in air 300,000 over 1.33. This will give you your answer for part B. Alright, we'll be taking up more and more examination style question on this topic once we finish a few more topics on it, because taking up questions solely on this topic will not be relevant before we understand more topics to get to the past paper questions. The next topic video will be on critical angle and total internal reflection.